Hi, everyone. Today we're going to be diving into one of the most essential macronutrients in our diets, which are proteins. These are often referred to as the building blocks of life, and proteins play a crucial role in our overall health, supporting everything from muscle development to immune function. Since I've provided other animations about proteins and their structures, functions, and metabolism within the learning module in Blackboard, in this particular presentation, we will explore protein sources, high protein diets, protein undernutrition, and briefly, food allergies and intolerances. So, first, let's take a look at some dietary sources of protein. They can be categorized into two main groups: animal sources and plant sources. Now, many people only think of meat as main protein source, but this is definitely not the case. Animal sources include foods like meat, fish, poultry, eggs, and dairy products. Um, these foods not only provide a significant amount of protein, but also contain all the essential amino acids, making them what we consider complete proteins. On the other hand, we have plant sources such as legumes, nuts, seeds, and whole grains that generally contain about less than 3 grams of protein per ounce. While these are crucial for a balanced diet, many plant proteins are considered incomplete proteins, meaning they lack one or more essential amino acids. However, we can remedy this by combining different plant sources like rice and beans, where you can create a complete protein profile. Now, when we talk about protein quality, we often refer to two types. We refer to protein as high quality proteins, also known as complete proteins, and there are those that contain all 9 essential amino acids in sufficient amounts. Examples include animal products and certain plant based sources like quinoa and soy. Now, there are proteins that are considered low quality proteins, and this gives a very bad connotation. Using the term low quality proteins, it doesn't mean that they're bad proteins. It just means they're incomplete. They lack one or more essential amino acids. Most plant proteins fall into this category, but by consuming a variety of them, you can still meet your protein needs. So, in summary, while animal sources are often regarded as high quality proteins, it's important to recognize the value of plant proteins and how they can complement each other in our diets. Balancing these sources is key to ensuring we get the nutrients that our bodies need. Now, let's talk about the recommended dietary allowance, or RDA, for protein. The RDA for protein is approximately zero point 0.8 grams of protein per kilogram of body weight for the average adult. This recommendation helps ensure that individuals get enough protein to support essential bodily functions and maintain overall health. So let's take a look at an example here on how to find our RDA for protein. We're going to be looking at a college student named Maya. To find her protein needs, we first need to convert her weight from pounds to kilograms. Since 1 kilogram is approximately 2.2 pounds, we can use the following formula. Maya is 5'6" tall and weighs 135 pounds. We need to first convert her weight to kilograms. So 1 pound equals 0.454 kilograms. We'll multiply her weight in pounds by that factor to get her weight. So Maya weighs about 61 kilograms. Now, to calculate her protein needs, we will multiply her body weight in kilograms by the RDA of 0.8 grams, giving us approximately 49 grams as her recommended protein intake. Now that you know how to calculate this, try it out with your own weight and find out your personal recommendation. This example illustrates how you can calculate your protein needs based on weight and emphasizes the importance of tailoring dietary recommendations to individual requirements. Remember that athletes or those with higher physical activity levels may need more protein than this, up to 1.2 to 2 grams per kilogram, depending on their goals. Now, how can we ensure that we're getting enough high quality protein in our diets? Let's explore the concept of protein complementation. This is especially important for those following a plant based diet. So, protein complementation refers to the practice of combining different plant protein sources to ensure you receive all the amino acids. As I mentioned earlier, most plant proteins are considered incomplete, meaning they lack one or more of the 9 essential amino acids that our bodies cannot synthesize on their own. The amino acids that plant proteins typically lack include tryptophan, which is sometimes less available in grains and legumes, threonine. Legumes are often low in this amino acid, but soy products are rich in it. Lysine, often low in grains like rice and wheat, or methionine, commonly found in legumes and beans, but low in grains. So, to ensure a complete amino acid profile, it's beneficial to combine different types of plant proteins. For example, and I mentioned this on the last slide, but if you combine rice and beans together, it provides a complete amino acid profile because the amino acids lacking in the rice are provided by the beans and vice versa. Other common combinations include peanut butter on whole grain bread, hummus with pita bread, or corn tortillas with black beans. By practicing protein complementation, individuals can easily meet their protein needs while following a vegetarian or vegan diet. And this highlights the importance of variety in plant based eating, which ensures a balanced intake of essential nutrients. Now, high protein diets have become increasingly popular for a variety of reasons. People use them primarily for weight loss, muscle building, and improving overall body composition. So let's explore why high protein diets are favored and the potential benefits that they might offer. First, one of the key advantages of a high protein diet is its ability to promote satiety. Protein is more filling than carbohydrates and fats because protein reduces your level of the hunger hormone ghrelin, which can help reduce overall calorie intake, making it easier for people to manage their weight. Additionally, protein helps preserve lean muscle mass during weight loss, which is critical for maintaining metabolism. A high protein diet may also stabilize your blood sugar by curbing the absorption of carbohydrates. For athletes or individuals focused on muscle growth, protein is essential for muscle repair and recovery after exercise. A higher protein intake supports muscle protein synthesis, aiding in muscle building and reducing an athlete's recovery time. However, high protein diets come with some potential drawbacks. One concern is that diets high in protein, especially animal-based protein, can put a strain on the kidneys, particularly in individuals with pre-existing kidney conditions. There's also the risk that focusing too much on protein may result in insufficient intake of other important nutrients like fiber from fruits, vegetables, and whole grains. High protein diets may include higher levels of saturated fat, especially when red meat or full fat dairy are the primary sources, which can increase the risk for cardiovascular disease, cancer, and osteoporosis. Now, protein supplements are very popular right now, especially among athletes, to boost protein intake and enhance performance, recovery, and muscle mass. Be aware, however, that there are general risks with their overconsumption, such as renal hyperfiltration and increased urinary calcium excretion. Now, this isn't very common if you're only using supplements, if you're not over consuming them. Now, on the complete opposite end of the spectrum is protein undernutrition, also known as protein energy malnutrition, or PEM. This is a serious condition that affects millions of people worldwide, mostly in developing countries, and we don't really see this in the United States because we do get adequate protein intake in general. There are two primary forms of severe protein undernutrition that I want you to remember: marasmus and kwashiorkor. Now, marasmus occurs due to a severe deficiency of both protein and calories, leads to extreme wasting of fat and muscle tissue. Individuals with marasmus look very thin, as you can see in this picture, with visible bones, reduced muscle mass, as the body breaks down its own tissue for energy. This condition is usually caused by prolonged starvation and can affect people of all ages, but most common in young children during periods of food scarcity. On the other hand, kwashiorkor results from a deficiency of protein in the diet, but with adequate or near adequate calorie intake. So, really, it's just an absence of protein. It's characterized by edema or swelling, particularly in the abdomen, legs, and face. And you can see the swelling in the abdomen in this picture on the slide. The lack of protein disrupts the body's ability to maintain fluid balance, leading to this swelling. And children with kwashiorkor may appear to have a rounded belly despite being malnourished. Other symptoms include changes in hair color, skin lesions, irritability, and an enlarged liver. Kwashiorkor is often associated with diets that rely heavily on carbohydrates like grains and starchy vegetables, but lack sufficient protein. So both conditions are very life-threatening if untreated, and they highlight the critical importance of protein in the diet for growth, development, and overall health. Treatment for these conditions involves nutritional rehabilitation, including the gradual introduction of balanced diets with sufficient protein and calories to restore health. Now, both of these conditions represent different types of protein undernutrition, each with distinct symptoms, but both resulting from inadequate nutrition. And proper dietary interventions and addressing food insecurity, which is a whole other topic, it's crucial in preventing these conditions. Now, over the next few slides, let's take a look at how proteins contribute to food allergens. We'll also touch on food sensitivities and a rare condition called phenylketonuria and what this means. So, how do proteins contribute to the development and manifestation of food allergies? This has been a nutritional hot topic over the last few decades. These proteins are called allergens, and the immune system responds by producing immunoglobulin E, or IgE, antibodies. The next time the individual consumes the same food, the IgE antibodies recognize the protein and trigger an allergic reaction. Symptoms can range from mild ones like itching or hives to very severe, like difficulty breathing or anaphylaxis, which is a potentially life-threatening reaction that requires immediate medical attention. Now, some of the most common food allergens, which I'm sure you're familiar with, are peanuts and tree nuts, like almonds, walnuts, and cashews, milk and eggs, shellfish and fish, wheat, and soy. And each of these foods contains specific proteins that the body may incorrectly classify as dangerous. Diagnosis of a food allergy typically involves a combination of a detailed medical history, a skin prick test, like you can see on the bottom picture in this slide, and blood tests to measure the presence of allergen-specific antibodies. Now, treating food allergies involves avoiding the allergenic food altogether. People with severe allergies often carry an epinephrine autoinjector, such as an EpiPen, which can stop a severe allergic reaction or anaphylaxis if used very quickly after exposure. Now, for less severe reactions, antihistamines may help manage symptoms like itching and swelling. However, the most effective long-term management strategy is just strict avoidance of the allergen. There are also new therapies under investigation, like oral immunotherapy, where patients are gradually exposed to small amounts of the allergenic food in a controlled environment to help reduce their sensitivity over time. And while this approach is promising, and I have had a few friends go through this, it's not yet widely available and must only be done under very strict medical supervision in case there is a response. Now, the stability, digestibility, and cross reactivity of proteins further complicate food allergies, but understanding the protein interactions is crucial in managing and treating food allergies effectively. Now, this is a very, very interesting topic. When I was young in the early 1970s and 1980s, I honestly didn't know anyone with a food allergy. Very few children in my school had severe allergic reactions to what we see now, to like foods like peanuts. From 1997 to 2011, food allergies in children increased by 50%, and from 2007 to 2021, food allergies in children increased by 50% again. So, what has changed? Over the past few decades, food allergies have been steadily increasing, especially in developed countries. There are several theories about why this rise is happening. And again, I just understand that these are theories, but they're very interesting to consider. One major explanation is the hygiene hypothesis, which suggests that cleaner living environments reduce our exposure to microbes, which are important for developing a healthy immune system. Without regular exposure to bacteria, viruses, and other pathogens, our immune system becomes more sensitive and may overreact to harmless substances like food proteins. Another factor is dietary changes. The modern diet, especially the Western diet, often includes more processed foods, fewer whole foods, and imbalanced fatty acids, and it may affect how our immune systems respond to allergens. Diets high in omega 6 fats and low in omega 3s, which are common in many Western diets, can promote inflammation and potentially increase the likelihood of developing allergies. The next one is the delayed introduction of allergenic foods. It's another important contributor because in the past, parents were advised to avoid feeding infants foods like peanuts or eggs until they were older. However, new research shows that early introduction of these foods may actually help prevent allergies. The delay in introducing allergens may have contributed to the rise in the food allergies that we see today. The next one is environmental factors. Increased exposure to air pollution and other environmental pollutants may disrupt immune system function, making the body more prone to allergies. Additionally, gut health plays a significant role in regulating immune response. Changes in our gut microbiome, possibly due to increased antibiotic use or changes in how we are born and fed as infants, could influence our susceptibility to allergies. Now, in conclusion, to wrap up the slide, food allergies are on the rise due to a combination of modern lifestyle factors, including cleaner environments, changes in diet, and how we introduce allergens to children. While more research is needed, understanding these factors can help us find ways to prevent allergies in the future. I will also link a couple of articles about genetics and vitamin D deficiency and how these could also contribute to the rise in food allergies. You can look for that within Blackboard. Now, we definitely want to take a look at something that we hear about a good bit, which is celiac disease. Celiac disease and non-celiac gluten sensitivity are two conditions related to gluten, which is a protein found in wheat, barley, and rye. While both conditions involve adverse reactions to gluten, they differ in terms of their underlying causes and long-term effects. Celiac disease is an autoimmune disorder. Now, when someone with celiac eats gluten, their immune system reacts by attacking the lining of the small intestine, causing damage to the villi, or the tiny structures that are responsible for nutrient absorption. And over time, this damage can lead to malnutrition, anemia, fatigue, and a variety of other symptoms, including digestive issues like diarrhea, bloating, and abdominal pain. Long-term untreated celiac disease can increase the risk of other autoimmune disorders, osteoporosis, and even certain cancers. Diagnosis of celiac is typically confirmed through blood tests in a biopsy of the small intestine. And the only effective treatment is a strict, lifelong gluten-free diet. And I have, again, several friends who have celiac disease, and they do struggle with it. It's a very difficult disease to manage, or disorder to manage. On the other hand, non-celiac gluten sensitivity, it's not an autoimmune condition, nor does it cause the same kind of intestinal damage as celiac disease. But people with non-celiac gluten sensitivity may experience symptoms similar to those of celiac disease, excuse me, such as bloating, fatigue, and headaches after they consume gluten, but without the immune response or intestinal damage. Now, since there aren't really any specific tests for non-celiac gluten sensitivity, it's usually diagnosed by ruling out celiac disease and wheat allergy, then monitoring symptoms, and improving on a gluten-free diet. However, this doesn't carry the same long-term risks as celiac disease, and the severity of symptoms can widely vary from person to person. Now we're going to take a look at food intolerances. Now, unlike food allergies, food intolerances don't involve the immune system. Instead, they occur when the body has difficulty digesting certain foods or components of foods, usually due to a lack of a specific enzyme. One of the most common examples is lactose intolerance, where the body doesn't produce enough lactase, which is the enzyme needed to break down lactose, which is the sugar in milk. This can lead to symptoms like bloating, gas, diarrhea, and stomach pain after consuming dairy products. Food intolerances can cause discomfort, but aren't typically life-threatening, and managing them often involves avoiding the problematic food or using enzyme supplements. Now, something else your book mentions, and I wanted to bring it up too, is a condition called phenylketonuria, or PKU. Now, it's a rare but serious genetic disorder. PKU occurs when the body is unable to break down an amino acid called phenylalanine. And it's found in many protein-rich foods such as meat, dairy, and artificial sweeteners like aspartame. This inability to process phenylalanine is due to a deficiency in the enzyme phenylalanine hydroxylase. And if left untreated, phenylalanine can build up in the blood, causing severe brain damage and intellectual disabilities. PKU is usually diagnosed shortly after birth through routine newborn screening and requires lifelong management through a strict low-protein diet and the avoidance of foods high in phenylalanine. People with PKU have to rely on specially formulated low-protein foods and medical supplements to ensure they receive enough nutrients without risking harmful phenylalanine buildup. Now, the label that you see on the screen here was taken from a diet soda with aspartame as the alternative sweetener. The FDA, or Food and Drug Administration, requires a phenylalanine warning on products that contain aspartame. So next time you consume a diet soda or see one in the store that contains aspartame, look out for the warning. So you can see on here, it says phenylketonurics, it contains phenylalanine. So in summary, food intolerances are related to enzyme deficiencies and primarily cause digestive issues, while PKU is genetic and requires strict dietary management to prevent severe health consequences. Now, the information on this slide is not discussed in this particular chapter, but I find it closely related and so very interesting. This is something, it's called alpha-gal syndrome or red meat allergy. It's a unique type of food allergy that's triggered by a carbohydrate molecule rather than a protein. So we're not discussing protein here. It's more typical. Protein is what generally causes food allergies, so this one is a bit different. Alpha-gal, or galactose alpha-1,3-galactose, is found in the meat of mammals like beef, pork, and lamb. This condition develops after a bite from the Lone Star tick, which you can see on the slide, which introduces alpha gal into the bloodstream. The body then creates antibodies to alpha gal, causing an allergic reaction when the person later consumes mammalian meat or other products containing alpha gal. So, what makes alpha gal syndrome different from common protein allergies is that it's a delayed allergic reaction, usually occurring 3 to 6 hours after eating red meat rather than immediately. And symptoms range from hives, stomach cramps, and nausea to more severe reactions like difficulty breathing or even anaphylaxis. Now, in contrast, protein allergies, such as those to peanuts, shellfish, or eggs, as we mentioned before, trigger a rapid immune response with symptoms typically appearing within minutes to an hour after exposure. So, alpha gal syndrome often requires special dietary restrictions to avoid mammal derived foods, while protein allergies are managed by avoiding the specific proteins that trigger the immune response. So, there could be an issue with your even though this is not caused by a protein allergy, it could affect your protein intake because you can't eat protein sources that come from mammals. Finally, be sure to read about plant-based diets in your textbook and the section on nutritional genomics, as it's a very interesting field of study that can have a big impact on the work of healthcare professionals. And I know most of you are looking to go into a healthcare related field. Rather than an across-the-board dietary approach, this field focuses on very personalized nutrition plans based on nutritional genomics and other clinical markers. It's very, very interesting. Now, I know this didn't cover everything in the book, in the textbook chapter, but I will have supplemental videos for you to watch to fill in those gaps or readings. But if you have any questions about this chapter or have anything else to add, please contact me and we can discuss it.